you will cooperate. Okay. So, yeah, I might as well just do it right here. The first step of this problem, they give you this, and then they tell you what x is. Oh, that's not going to work, is it? It's going to suck. All right. When you plug a 4i in, if you haven't tried this yet, just plug a 4i in. Just replace x with 4i, right? That's all I want you to do at first. And then you might say, well, what the hell else can I do? With me, so you'll get y equals what? What do you get?
1 plus 4.
8i. I like it. Over 4i plus 3. And I wouldn't blame you if you just were like, okay, I did that. Next problem. But there's an issue. What's that asking you to do? Divide. Yes? So you're not done. You haven't divided yet. So then you're like, how the shit do I divide that? All right, so let's remember a few things very quickly. What is I, by the way? What is I?
Square root of -1.
Yeah, I do b squared root of -1. I love it. Okay? I love how my grammar gets really bad when I talk about complex numbers. What is I? So I is a radical, yes? So whatever I do with radicals, I very often can do similar things with I, because i's are radical. So, here, there's a problem, a division problem with a radical in it. Simpler than the one we're looking at, of course, but still, we've got to build our way up here. To do this, it's a little weird. We do something, does anyone remember how to do this problem? It doesn't close, don't worry, it's not you. Okay. Does anyone remember? Yeah. Good. Why can I not do the square root of 7? Okay, why can I do the square root of 9?
Because it's not divisible, but
9 is made up of 2
Yeah.
3s. Why can I not do this? Because square root of 9 has 2 3s in it, and square roots are looking for groups of 2 things. Does that make sense? So why can't I do the square root of 7? Because it's only got 1 7 in there, right? So how many more 7s does it need? So that I can do the square root. How many? It needs 1 more 7, yes? You guys with me?
yeah.
So if I could just multiply the bottom and somehow get a 7 in there, I could do something with it, yes?
Yeah.
So a couple things. I can't just multiply the bottom by 7, because it won't go in there, and I'm not allowed to multiply just the bottom of a fraction, yes? If I want the 7 to go in, can I multiply by 7 and it goes in? What do I have to multiply by?
Square it.
Square root of 7. And whatever I do to the bottom, I have to do to the top. I don't know if you guys remember, this is called rationalizing the denominator. Good Lord. Okay. That's a long-ass phrase, right? But it's just making the bottom not rational. Not irrational there. You want to make it rational. So what do I get on the bottom now?
7.
Good. Half of 7 times half of 7 is a whole 7. On the top, do I get the square root of 14?
No.
You have 2 radical 7.
Yeah, I don't. The 2 is not in a radical. I can't put it in with the 7. That's a whole 2 and a half of 7. So it's just 2 rad 7. Now I understand on one level that is a little disappointing. I don't feel like we actually divided, Jeff, but we did as much as we could. Radicals kind of suck. Do you guys agree with me? What's the square root of 11? I don't know, right? So they really suck when they're also on the bottom, right? So 5 is beautiful. 2 over 5 kind of sucks. 2 over square root of 5 sucks big time. So in general, we don't want radicals on the bottom. We want to get them up top. Okay, maybe. This whole idea is going to become huge when we do trigonometry. If you don't know what trig, somebody know what trig is? Yeah? What's it involve?
Triangle?
Triangles, sine,
Like
cosine. If you don't know what the hell it is, you're fine, because you're in the right place. We're gonna talk about it later. So that's gonna become big time later. What's wrong with this guy? Why can't I do that, this one as easy as I did that one?
They're complex numbers.
Huh? No, number 2. There's no complex numbers in there.
Oh, okay. So complex numbers.
Trying to engineer something stuff.
You got different,
This was easy, because if I multiply it, it only affects this, so I can get to it directly. Yeah.
Before we move on to 2, where did that 7 come from?
This guy?
No, it's like.
This guy.
2 over the square root of 7, yeah.
Oh, this was the problem.
That,
This is me saying simplify this.
oh, okay.
Yeah.
I thought that was according to 10. I thought that.
No. These are my steps building up to 10.
I see,
Yeah,
I
yeah.
see.
Sorry. I love it, because you're over there going, how the shit do I get? So I'm sorry.
Yeah.
These are kind of leading up to the idea of how to finish number 10.
Okay.
Yeah. Do you guys agree with me that if I try to multiply by square root of 7, that'll make this become 7, but then this will still have a square root,
Yeah.
it'll be 2 square root of 7. It doesn't accomplish what I need. Damn it. So whenever there's more than one term on the bottom, that desperately sucks, right? I don't know if you guys have ever done long division of polynomials
Oh,
before.
I bet it doesn't really.
That's something to look forward to. We're going to do them later. This is the best. Sorry.
I was thinking about a complex number again, and it's not a complex.
Not yet.
Yeah, okay.
Not yet. So watch what I can do. If I multiply by something related to difference of squares, if I multiply by same things, opposite sign in the middle, let's see what happens. So I'm going to multiply by 2 minus square root of 7. So help me out. Help me FOIL the bottom. What do I get?
4?
Yeah. And then I get plus 2 rad 7 minus 2 rad 7. Right? The only place a radical could have shown up is dead. And then at the end, what do I get? What's rad 7 is rad 7 is 7. Good. Right? So the bottom is now rational. By the way, I keep using that word. Inconceivable. No, anyone know what rational means?
A number pertaining to a ratio.
Yeah, so it's what kind of number?
Fraction.
Fractions. I love it. So, for example, what do I get on the bottom? I get negative 3. Is that a fraction? Yeah, negative 3 over 1. Nah. So that is rational. Damn it.
When I was a kid, there's 2 problems that I just couldn't get past, and nobody ever explained them to me. I was like, well, why do you say this number's irrational? I think it's a perfectly rational number. And then they say the least common denominator. So how do I know if a denominator is any more or less common than another one?
Ah, I love it. So, guys, while I give up on the door, can you foil the top? You guys see what I mean? We did the bottom together. Foil the top out.
Okay.
That's kind of what we did before.
That doesn't work. Give up. Time out.
It's like driving each other. Yeah.
Yes.
I got a question just about the bottom part. So on the top, obviously, like you wouldn't put a negative, but whenever there's 2 numbers on the bottom, you can switch it to 2 minus, right?
If you put what now? Sorry.
I'm talking about before that part. So it's 2 plus square root of 7, and then you switch it to 2 minus. Is that because there's 2 different, or there's 2 numbers?
Yeah. So this idea is related to difference of squares, where the middle term cancels, and the middle term is the only place that could still have a radical. All right, what do you guys get for the top here?
6 radical 5.
6 rad 5.
And 3 rad 7.
3 rad.
Square root?
Yeah, so it's 6 rad 5. And then 3 rad 5 times rad 7 is 3 rad. What's rad 5 times rad 7? Rad 35. There you go. What's a whole 5 times a whole 7?
35.
What's half of a 5 times half of a 7? Half of a 35. That's all, right? That's why the root has to be the same to be able to multiply them, because it just tells you how much of that number you got. So I got a half of 5 and a half of 7. That makes a half of 35. Okay, so now we got this. I'll do that one. Okay. And then you get -1 times negative rad 7 is plus rad 7. Any like terms or anything on the top? Like terms? Nope, I'm done. Right? You with me? No? You guys not like that? All right, so each step of this, we know how to FOIL. Twice 3 rad 5 is 6 rad 5. 3 rad 5 times rad 7, well, that's 3 rad 35. I can put together the numbers that have the same root, right? So if you just do the FOIL step by step, you'll be golden. Does everybody understand where this came from? Where did I get that from?
The bottom.
Yeah. And the name of that doesn't matter as much, but it's called the conjugate, right? If anybody ever took a foreign language, you have to conjugate your verbs. This has nothing to do with that. It's just math going. I like that word. Let's use it for something else. All right, let me stop for a minute. So can somebody tell me why this problem we just did directly relates to this problem right here? What makes that problem as bad as it is as a fraction? Why is it a worse fraction? Because what does it have in it?
Square roots.
And what is I?
Square root.
So the way I do this should be the same as the way I did that, because they both have radicals in them, right? So what am I going to multiply top and bottom by for this guy?
4i minus 3.
Kick ass. Check, you can do it. Multiply by the conjugate. Again, it's a difference of squares idea to make sure the middle terms cancel.
So you get -9.
Let's see. On the bottom, you get, what's 4i times 4i?
8i
69.
squared.
16i squared. The middle terms cancel, yes? Plus 12i minus 12i. I like it. I feel like you're holding me up. Sorry. And then 3 times -3 is -9. That's crazy, Jeff.
So I squared is -1.
Good. I squared is -1.
So it'll be -16.
-16 minus 9,
25.
-25. So we got the bottom figured out, and the top, you just got to FOIL that shit out. So you're trying to make the bottom as nice as you can, but that just means the top could get gross. But if you have a really gross number, I'd rather have it on the top instead of the bottom. I'd rather have it on top instead of divide by a gross number. So now on the top, you just FOIL it out. 4i minus 3 plus 32i squared minus 24i. And then you put your like terms together. 32i squared is -32, minus 3 is -35. Minus 24i plus 4i is minus 20i. I think that's right. Become a thing. You guys okay with that? It's really just all foiling. Yes?
Sorry, how did you get -25?
I don't know. Whoa. Here. Are you cool with 16i squared minus 9? Is that okay?
Yeah.
Okay. What's I squared?
Negative, I don't know.
Uh-oh. All right. So what's I?
The square root of -1.
So when you square it, doesn't the square root go away? So I squared is -1.
Okay.
16 times -1 is -16, minus 9 is -25.
Oh.
Now be careful, I always get people that start replacing I with -1. Is I -1?
No.
That wouldn't make any sense, because we're cool with -1. Why do we have to give it a letter? I'm totally cool with -1. Square root of -1, freaky as shit. Let's give it a letter so we don't have to look at it, right? Sort of like my sunglasses in my eye. It's a little freaky. All right. And then what's the last thing I could do with that? You guys see I can do something? Everything is divisible by, and in fact, it's divisible by -1. So this will be, yeah, there's 6. This will be 7 plus 4i over 5. So divide everything by 5. So you should be cool with foiling, you just have to be. You need to be cool with I squared is -1. The only kind of new thing is, where the shit did that come from? Well, it's based on whatever the hell that is. And then it just becomes a bunch of foiling, right? Yeah?
On the top for like the first one, when you divided the bottom, so like the very top, like
No problem, I.
Oh, number 1, problem 1, okay. Sorry, I use Roman numerals for that, which is confusing because we got complex numbers, I'm sorry.
When you divide it by radical 7 on the bottom, like for both top and bottom, you multiply by it, you didn't do a negative like you did.
Totally not.
Yeah.
When the bottom is one term, I've got nothing to worry about. I can just attack that term. When the bottom's 2 terms, oh shit. Now I have to do something so that stuff cancels. I need this to make sense. If I didn't have the middle terms cancel, would I still have i's running around? If those didn't cancel? So when the bottom is more than one term, that will eternally suck. So watch this real quick. I'm not going to make us do this whole thing, but if I had x squared plus 4x cubed minus x divided by x, could you guys do that? What do I have to do?
Just take over.
Just the top loses an x, right? Just divide each piece by x, is that cool? So then I would get x plus 4x squared minus 1, what do you do? Let me see we're not going to do this problem right now. We're going to do it later this semester, but let's see if you guys react to this. Become a cube again. Is that as easy to do? Hell no. This would be long division of polynomials, or something called synthetic division, which you will come to love.
Oh, yes.
Synthetic division kicks a lot of ass. Do you guys understand? If I break this up, I can't do shit. I cannot do shit. Can I kill an x? Can I cancel the x? Why not? Why can't I not cancel the x?
Because there's a 1.
Because division does not cancel subtraction, yes? If you ever catch yourself canceling something, just go, what are the operations? Are they actually opposite? Because that's the only time something can cancel, yes? Okay. I understand our brain goes, sweet, no, but you don't, no brain. Can't do that shit. Maybe? Yes?
Why did you simplify the last problem to get the -35?
Oh, I'm sorry. So I squared is -1, correct?
Yeah.
So then I get -32 minus 3 is -35. Yeah. I just didn't want to keep writing stuff. So we know I squared is -1. So basically any term that has an I squared on it just becomes the opposite sign, right? -5i squared becomes 5. Because I squared is -1. Is that okay? I like that. I feel like some of you guys are doing this just to make me feel good. I don't know. Is it really okay?
Bobbleheads.
Because I squared is -1. So if I multiply anything by a squared, it just changes its sign. Okay. Now some of you guys look like, oh shit, this guy can't explain anything. All right. Cheer, you can't see it. All right. So that's this deceptively difficult problem, right? Oh, we just did that one, didn't we? Oh well. There's a freebie for your homework.
Yay!
I know. Anything else from homework while we're looking at this? Did I leave a stack of stuff back there? Yes. Did anyone not get the answer key for that factoring handout? Did anyone not get the factoring handout? Oh, the answer? You got, okay.
Would you be able to, either 20 or 30 of 2.4?
Yeah, let's find out. 20 or 30. Oh, well, all right. Real quick, 20, which I currently have stuff written on. 20 would be just doing what?
Foiling?
No, come on, just distributing. By the way, real quick, just there. I told you guys that I wish we never invented the word foil. Yes, not for like putting your baked potatoes in, but foil and math. Very quick word about this. Very quick. If I have this. We don't need foil, it's bullshit. Bullshit, bullshit. How many things are sitting in front of the x minus 7? 2, right? So the x distributes and the 1 distributes. I don't need frickin' foil. It's bullshit. So, I have strong feelings about something so trivial, I'm sorry. Because if I put one more term in there, foil is not helping. Foil means first, outer, inner, last. Now I got an M for middle. First, middle, first. So if you just look at it like repeated distribution, he gets a turn, he gets a turn, you get a car. Okay. Right? It's just repeated distribution. I don't need some stupid FOIL. All right, I'll stop. I'm sorry. I feel like when math teachers do that, when we do that, we're saying, oh, this is so hard. Well, let me help you by giving you a little mnemonic. No, it's just repeated distribution. It's not hard. All right, I'll stop. So this is just straight up distribute, right? The one thing to be careful about when you're doing this kind of stuff with I is I squared, you can go further, right? If it was x, I'd stop at x squared, but it's I got to go one more step, right? Is that okay? Okay. Looking at number, what was it again, 30?
30, yeah.
All right, why is that one better than the one we did a minute ago with 4i plus 3 on the bottom?
You can just multiply by 2i.
Yeah, the bottom is only one term, so I can just multiply top and bottom by 2i. Sort of like we multiply top and bottom by square root of 7, because there was just one term, I could just attack it directly. Yes?
Would it be negative 2i?
No.
Okay.
And because it's only one term.
Okay.
When I did the first problem, we just multiplied by rad 7. We didn't multiply by negative, right? Because I didn't have to worry about making something cancel because I have too much shit. Here I got one thing.
Okay.
I don't have too much shit. Yay. Yes?
So for 33, you multiply by the opposite, right?
Yeah, what would you multiply 33?
2 plus i.
2 plus I on top and bottom. Kick ass. Yes. 35? It's over there, here. Oh, okay. What's the square root of 9? 3. What's the square root of negative 9? What's the square root of 1?
1.
What's the square root of negative 1? I. There you go. So what's the square root of 9?
3.
What's the square root of negative 9?
3i.
3i. Bam. Right, so watch this. Made it sound like you wanted you to watch me erase the board. It's amazing. Do you remember how to do square root of 50?
Okay, it's gonna be like 225.
Yes, so you want to break that up into a part you can do and a part you cannot do. Very quickly, you guys, how do you make that into a mixed number?
Oh,
Watch this, here's a cool way you can do it. You don't have to do long division. Don't you wish the top was 7? Yes, wouldn't that kick ass? So what isn't 7 plus 4? Do the part you can do, leave the part you can't do, done, right? Right? Nothing amazing, nothing amazing. Same thing here. Square root of 50, let me break it up into a part the square root can do, and then whatever the shit else. So like Mike said, I can do the square root of 25, and what else has to be here?
Square root of 2.
Yeah, what's the square root of 25?
5.
Crazy, what's square root of 2? I don't freaking know. We didn't change the number, we just simplified it. I like to call that reducing the radical. But it's not really the official, it's just simplifying. You guys semi with me? A little tiny bit? Physically at least? Okay. What did that relate to? What got me on that?
35.
35. Oh, yeah, okay. Jesus, Jeff. So square root of negative 9. Square root of 9 times square root of?
30.
1.
No.
Negative 1.
Negative 1. Doesn't that make square root of negative 9? What's square root of 9?
3.
3. What's square root of negative 1?
I.
I. Do you ever have to do that again? No. What's the square root of negative 25?
5i.
5i. Bam! We're better than that shit now, right? We don't have to do that shit. We know what the square root of negative 1 is. So the square root of a negative number will have an I. Here's something interesting. What about the square root of negative 7? Do the part you can, leave the part you can't. Can we do the square root of negative 1? Sort of, yes. But so what's the square root of negative 1? I. What's the square root of 7? I don't know. Maybe? If you say so, Jeff. All right.
It's not rad 7i, it's I rad.
Well, the reason I don't write rad 7i is because sometimes this can extend.
Oh, okay.
So you normally put them out front. One of my students said we should have put a back wall and the square root symbol, and I agree, but oh well. Do you see what I mean?
Yeah.
Think about this for a second. The square root of I.
Square root of negative 1.
No, because I is not negative 1.
Oh.
That would be the square root of negative 1. Stop thinking about it. Okay. Just wanted to throw that at you. That's why you don't want to make yourself think you have the square root of I somewhere, because that's really freaky. You guys all right? Okay. Anything else from homework? Okay. I think the last thing we did, I gave out this handout. Let's see if it comes up, yes. We did completing the square. So what I would like you guys to do right now is to do number 1. If you haven't done it already, try to do number 1.
The one we got yesterday?
Let me know if you need this sheet. It's the one that says quadratic equations at the top, is that right?
Completing the square.
Oh, it says completing
One
the
says
square.
solving quadratic equations, the other side says completing the square.
Yeah. So one side is all the different ways to solve, and the other side is that.
Are
Does
we
anyone
doing
need that?
completing the square first?
Yeah,
So
number
number
1, completing the square, yes. So I want you to do this problem. Just to really make sure, I do not want you to use quadratic formula, right? Sure. Does anyone else need this paper? Yes. Anyone else need this paper? Okay.
What is that?
I don't know. I found it in the floor. No. Do I have one left for me? This one I gotta keep too. It's the one that says completing the square on one side.
Oh, yeah, okay.
Yeah. So number 1.
Okay. I'm looking at the wrong side.
There you go. By the way, I'm going to say this a few times, especially in the beginning of this class. If we do something and I say, does everybody get that? And you look around and you're like, everybody else gets it, I'm not going to say anything. No. There are people lying to me when I ask that question, right? There are people doing this who are like, I don't have a clue. So just say something. Again, I think I've told you this. It's my job to keep this class on pace. It's your job to just ask any question you have, right? If there's too many questions and I gotta keep going, I will tell you. Don't self-censor. Does that make sense? I will not let you slow us down, but I need to know when there are questions. Okay?
So we supposed to do that?
Yes.
Okay.
So let me make sure everybody got the right first step here. If I want to complete the square, where do I want to have a blank space to work with? Where the what is?
11.
11.
So get that the hell out the way first, right? So you have some blank space to work with. Does that make sense? So what's the first step you want to do?
Add the 11.
Add 11. 11. Kick ass. Yes. Oh yeah. Yeah. And now just root.
Oh.
Yeah. Because the whole problem is your X stuff is stuck in a square, so you just want to kill it. And don't forget what you have to do when you put a square. Plus or minus. Yeah.
I keep seeing this half right here, but I'm not sure how to get that.
Oh, so the middle term. First step is cut it in half. So what's the middle term here?
6?
-6. So the first step is cut that in half.
To be 3 and -3?
Well, it'll be -3.
-3, okay.
And then you square.
Okay.
And then it's just a question of, do you know where each of those goes? Right?
So.
All right, let me catch up to you guys. First step, add 11. Then you have the two little steps. First step is cut the middle number in half. The really cool thing about that is how this will eventually factor. I don't even know what the damn thing is yet, but I know it's going to factor like x minus 3. Now, why does that work? For all the reasons we talked about yesterday. We did a bunch of problems, we got motivation, we saw how this worked, and now we made a process out of it. Maybe? Just to remind you guys. Just to remind you guys. If I FOIL this, what do I get?
X minus 5x plus 5.
Yeah, minus 5x plus, minus 5x minus 5x minus 10x, yes?
Oh, yes.
Right? Let me write this. So we got 2x minus 5. X squared minus 5x minus 5x is minus 10x plus 25. How does that relate to this? How does that
25
relate to this?
It's the square.
Square. How does that relate to
It's the
this?
sum.
It's double.
Yeah.
That number. How does that number relate to this number? It's twice that number, yes? So if I started here, how would I figure out what number goes there? Cut that in half, yes? How would I figure out what number should go here? Square what I just got. Why? Because that's how it works. You guys see that? So much math is just doing something and going, oh, this always happens. I can make a backwards process. Maybe? So it's one step to memorize the steps. Okay, that's good. If you can do that and you can apply it, great. It's the next level to really know why the steps work. Right? What do I do with this number now? Square it. What does that tell me?
Positive.
Put a plus 9 right there, right? If I add 9 to this side, I better freaking add 9 to that side, yes. So the first step tells you how it will factor, and the second step tells you what to put there to make it factor. So why do we call this completing the square? Because I took this thing and I put it in a form that can be written as a square. Now, the next good question is, good job, Jeff. What the shit did that do for me? Right? Well, now, why can't I just directly solve for x? Stupid square. So then I just kill the square. So this dies. How do I do square root of 20? Break it up. Oh, sorry. Good. Good. Square root of 4, square root of 5. Square root of 4 is 2. Square root of 5 is I don't know. I don't know why I'm doing this all out today. Don't hurt me. All right. And then what's the last step to solve for x? Add 3, so I get x is 3 plus or minus 2 rad 5. Weehaw! Yes?
How did you get 2 radical 5 from 20?
Oh, what is square root of 20? Isn't that square root of 4 times square root of 5?
Yes.
Isn't square root of 4 too?
I see.
Yeah.
Wait, so are we factoring by grouping?
Which part?
After you get x squared minus 6x plus 9.
Well, that's just straight up factoring, right? What two numbers multiply 9 add to be negative 6?
Yeah, what's the step after that? Why?
Well, again, what two numbers multiply by 9 add to be negative 6?
Okay.
Now, I really want you to understand, you actually don't have to factor that because the first step told me the answer, right? Why does it tell me the answer? Because we made it that way. We created this process. You guys helped me out. Now, to be honest, it was made a long time ago, but we at least explored why the hell it works, right? So don't be like amazed that happens. Of course it does, because it came from what we noticed. We forced it to do that for us. That kicks so much ass. Look at the next problem. Why does the next problem suck? Let me see if you guys pick up on this. Why does that problem suck? What was true about this first coefficient? So 1, for completing the square to work, this must be a 1. So what do I have to do first thing here?
Divide by 9.
Holy shit. Which is not as bad as it could be, to be honest, but it's still kind of bad. You'll see.
Because you have to do it divided by 5.
So let's do this together. Here we go. What do I got? I got you. Come here. Okay. All right, guys. All right. Well, let me erase that so it's not. Everybody got what they want from this? Oh, sure.
It's on the video.
Just don't look over there if you're looking at this. Okay. So if I divide by 9, divide by 9, divide by 9, I get x squared plus 3x equals. Oops, shit. Sorry. 5, 9. Okay. Is that all right so far? Now, I don't know if you really agree fully with what I'm about to say. Completing the square is powerful as shit, but the reason it's powerful is it's built off of the first coefficient being 1. If I built a process that the first coefficient be whatever, it would be a lot more complicated. So therefore, I've just got to make sure the first coefficient is 1. Which could lead to weird shit happening elsewhere, but oh well, too bad for us. What's the first step to complete the square? That's why I left room here, right? What's the first step?
Divide 3 by 2.
Yeah, first step is 3 divided by 2.
1 point. Sorry.
Thank you. And then we take that number and we square it. Let me erase. Can I erase this now? Okay. Which is?
9 over 4.
All right, let me stop for a minute. This is what I mean when I say the process doesn't care what's in there. The process is just the process. We care that it's fractions, but the process doesn't change. So, help me out. Where does that go?
Where did you get the 9 over 4 from?
All right, so first step is to cut the middle term in half, right? So 3 halves. Second step is to square what I just got. 3 squared over 2 squared.
But where did 9? wouldn't it be 9 over 5? Or 5 over...
3 squared is 9, 2 squared is 4.
Oh, okay.
Yeah. Okay. So where does this go?
X at 3x.
Yeah, so if I add it here,
That's your side too.
I better add it here. And how does this factor?
X plus 1 or 3 over 2.
Yeah, it tells you already, right? So no matter how ugly this part gets, you already know how it factors from the first step. Alright, so again, whatever the middle term is, I cut it in half and then I square it. Why? Because that's how it works. That's what we saw, right? When we looked at the patterns, that's what we saw. This number is what I have to add to make it work, and this number tells me how it will factor. What do you get over here?
101 over 36.
101, oh, I see, okay. 20, yeah. 101 over 36, I agree. So you have to make LCD, is that cool? Multiply this guy by 4 on top, bottom, multiply him by 9. Oh, you guys love this. Alright, it's a little worse than it was, but it's nowhere near as bad as it looks like it could be, to be honest, because what's the next step?
Squared.
Yeah, that square is in my way, right? If that square wasn't there, I could subtract 3 halves and be done. Stupid square. So we square root both sides. What do I put?
Plus or minus.
So I get, bam, x plus 3 halves equals plus or minus, what's the square root of 101? I don't know. What's the square root of 36?
6.
6. Yes.
Where's the 1 over?
Oh, sorry. Multiply this by 4, right? And multiply this by 9 to get LCD.
Oh, okay.
So you get 20 plus 81.
I thought you
over.
were just multiplying across.
That would be neat. No. So, the real quick thing about LCD. Is 9 prime? Is 9 prime?
No.
Is 4 prime?
No.
Let me throw something at you. 9 and 4 are relatively prime. Do you see what I mean by that? 9 and 4 are relative. Do 9 and 4 share any factors besides 1?
No.
So they are relatively prime. Anytime you have denominators that are relatively prime, they each need each other. Aw. So like the first dude needs a 4, and the other guy needs a 9. The only time the LCD is not just those multiplied is if they share a factor. If they're not relatively prime. Like what's the LCD of 1/8 plus 1/4? Is it 32? 1/8 plus 1/4, what's the LCD? 1/8 plus 1/4, what's the LCD? 8. Because you can make both bottoms become 8, right?
1/8 and 2/8.
I don't know if you guys are with me here. So why was this LCD 36? Because 9 and 4 are relatively prime. They each need each other to become the same thing. 8 and 4 is in 8. They're not relatively prime. The LCD would not be 32, yes? Okay. Yes?
So how did you get 1?
Okay. To get LCD, this guy needs a 4. This guy needs a 9. 20 plus 81. So again? Right, just to get an LCD, right? This guy needs a 4, this guy needs a 9, so then they both have a 36, right?
Yeah,
And then I can add them together, yeah. Okay.
I got it.
Okay. And then what's the last step?
Subtract 3 over 2 on both sides.
So I'll get x equals negative 3 halves, give or take, square root of 101 over 6. Yes?
Say we're taking a test, right? And we accidentally forget to put the 6 with that like talk down points. Like just leave it as 36, square root of 36.
Oh! Yeah, if you just leave it in the square root, I might not take off anything. I'll just have a little note. You know? It's just, but you have to do square roots wherever you actually can, right? Yeah, that's not that big, but that's what I call not a conceptual problem. Conceptual problem would be
Just completely different.
you I don't know. I get people that solve for x just by moving shit over and square rooting, and then both sides have an x on it. I'm I'm like, okay, that's a conceptual problem, right? Okay. All right. So on the yesterday we actually derived the quadratic formula, which if you missed it, I don't know if you feel bad about that, but it's down here. We actually saw where that came from. So this side has all the various ways to solve quadratic equations. You can factor. You can just straight up square root both sides, if it's in the right form, right? You can complete the square, so you put it in the right form. Right, so if you complete the square, you actually put it in the form, you can just square root both sides. And then of course you could do quadratic formula, which is just completing the square more directly. It's like a shortcut sort of completing the square. Okay, how you guys feeling? So do this for me. Here. Solve this using completing the square. Yes.
So essentially, whenever factoring and the square root principle don't apply, you can kind of choose like either method, the
Yeah.
or completing the square.
I wouldn't blame anybody if I don't say you have to complete the square. I would think most of us would default to quadratic formula. Sometimes completing square is quicker, believe it or not, but yeah. If I don't say complete the square, then you can just use quadratic formula, right? Here, I said specifically, complete square. You can call me over if you need some help. So, oh, no. That side, so on the side, that's why I keep doing the little 1, 2 on the side. So put over here. Put over here, put like A or 1 or some, whatever you want to do. Yeah. So the first step would be cut -5 in halves. I'm sorry. So I mean like to, I'm sorry. So what I do is I normally, I like to use little Roman numerals. So step 1 is cut the middle term in half. So -5 over 2.
Okay.
You would put that here. Step 2 is whatever you just got, what would you do to it?
Square.
Good. So square top, square bottom. Yeah, not double square. And it won't be negative anymore, right? Because you square negative is positive. Cool. The first one is how this will factor. The second one is what you have to add to make the factor work.
So what do I do with the 25?
That's what you add to both sides.
Okay, got it.
And then the step after that would be x minus 1 halves, because that's the part that tells you how it's going to factor.
Okay.
Yeah. I'll catch up to you. Oh, I see. Okay, got you. Yeah, it looks good. Okay. Yeah, good. And then that's as but here, the way this factors
Oh, no, just, that's just a problem. Like, you just solve it with it, so you add it to like the 2 and a 4, you just keep on solving it. Like, it's just part of the equation. So just complete the square in the middle, that makes sense.
First step I did was I took a 2 out.
So what did I do? I know I got this one. You did.
How'd you get 4x plus 2? Isn't it 2x plus 4? Then we'll agree. So you just took the GCF out last. I took it out first. They both will end up in the same place, yeah.
And then don't you combine the x plus 2 though?
All right, guys. One mistake some of you guys are trying to do is you're not doing the side work on the side. You're trying to like incorporate it as you go. Don't do that to yourself, right? Every time I've done this, I had a little side work. Here's a little side work. What's the first step?
Divide 5.
Yeah, take -5, cut it in half. What's the second step? Square that. Oh, thank you. I was wondering where I put that. So read with me so far.
Yes.
That's relatively easy to memorize, right? It's really nice if you know why it works, but you don't have to know why it works for every problem. You just do it. Now you just got to remember what goes where. Where does this guy go?
On both sides.
Yeah, that's what you add. That is the number you must add to make this factor nice. And the really beautiful thing again is you don't actually have to factor it because it already told me how it factors, right? Over here, LCD, yes? Multiply by 4. 8 plus 25 is 33. Can we stop for a minute? Maybe another full minute. Okay.
What did you just do with that, too?
Multiply by 4 on top and bottom and make it have an LCD with 25 fourths. Right? Isn't 2 over 1? Any numbers over 1, yes? All right. How do I add 2 plus 25 fourths? I need an LCD before I could do it.
Okay,
So I need to give this a 4. So now they're both fourths.
okay,
8 fourths plus 25 fourths is 33 fourths.
okay.
Okay. Now what do I do? The reason I can't just add 5 halves is because it's all stuck in what?
The parentheses.
Stupid square, right?
Yeah.
So I square root to kill it. What do I put here?
It's rad 33 over 2.
Kick ass. Square root of 33, I have no idea. Square root of 4. 2. And on this side, what do I have?
X minus 5 halves.
Yeah. So then I have one more step. Add the 5 halves. You could put this 5 plus or minus right through 3 all over 2 if you want to, right? Because they both have 2 on the bottom. Now, can you redo that problem? Let me write it again. What was it? Equals 2. Let me do one thing for you. I want to use quadratic formula. Yes, sir?
How did you get 33?
I don't know. Oh, are you cool with this? It has a 4, so I need a 4 under the 2. Multiply by 4. 4 times 2 is 8. Plus 25. Okay. Remind me, guys. Before I use quadratic formula, what must the thing equal? What must I have the quadratic part equal to?
0.
0. How do I make that equal 0?
Minus 2.
Subtract 2. Can you guys please attack that with quadratic formula? If you forgot it, oh shit, but you had it on your little sheet, right? But you gotta know it. Yeah.
Since they're both
Oh, sheet.
have the common or denominator two.
Totally, it's 27. So you, if you wanted to, you could put 5 plus or minus rad 33 over 2. Totally, but I would take either way. Yeah. There we go, Jeff. So if you want, you know, this is where you have to know what A and B and C are, right? What's A?
1,
B?
Negative 5.
-5. C?
-2.
-2. Kick ass. So now it's just plug and chug, right? Plug and chug. I would think this is the one you're a lot more familiar with than completed square, right? So how's it go? X equals negative. Good, -5. So 5, give or take, square root of squared. -5 squared is 25. Minus 4 times
1.
A times C. All over 2 times 1. You can, it's 2A, right? You see how we got it over 2 already? And you do realize we're going to get the same damn answer because it's the same damn problem, right? So let's see. And we already get the 5. Look at that. So we got 5 plus or minus. What happens in here? 25
Plus 8.
plus 8. Did we get the same answer?
Yes.
Of course we did. It's the same shit. It's the same shit. So quadratic is just completed a square shortcutted. That's all. You see right here, didn't we get 25 plus 8? Right there? Didn't we get 25 plus 8 right there? It's the same shit. It's the same math. It just is organized differently. That's all. Maybe. Okay. Okay, so you just got to get in there and try it. This is all from section 2.5, right? Quadratic equations. I want to do a little new stuff before I let you out of here. So we got this stuff here. I'll leave the quadratic part up there. I think we got this here.
Oh, you got it on YouTube anyway.
I got it up on the YouTube. All right. So let me just say something and see your reaction. Functions. What's a function?
Something that
Conjunction.
Oh, vertical.
Oh, okay. All right. So I could ask this. I'll ask a slightly different question that answers. Tell me anything you know related to functions. So somewhere there's a vertical line test. Does that sound familiar?
Something that you plug in and you can use something else out.
I like it. Something you plug in, you get something else out.
It's only got
You're
one.
trying to get the values on the x-axis.
Oh, okay. So part of it could be trying to get the values on the x-axis, which are the x-intercepts. Also called the roots, because that's where plants have the roots, right?
For any input, it's only got one out.
Beautiful. I don't know if anybody's ever seen Highlander. Does that sound familiar to anybody? Highlander?
There could be one.
There can be only one, exactly. All right. So no, if you didn't, again, you don't have to watch Pulp Fiction. You don't have to watch Highlander. I'm sorry, but some of my references so well. So what we have something called a relation between variables, right? And this would be just any relationship between any variables at all. So, for example, if I ask everyone in this room, what size shoe are you wearing on your left foot? Would there be a relationship between person and number indicating size of shoe? There would be a relationship between those two, correct? You with me? That's less mathematical than you're used to, but that's an example of a relation. A relation doesn't have to be mathematical. Is there a relationship between miles per gallon and model car?
Yes.
Yes, generally, right? Doesn't really adhere to it, but we can go strictly by the EPA. EPA is always too high, so, oh well. You guys all with me a little bit? Okay. So, when we're talking math, here's an example of a relation. No, Jeff, get that out. There. Okay. That relates an input number with an output number, right? Oh my gosh. Okay. It's an atmospheric class next door. Thunderstorm. It's funny because I know Steve is next door, one of my colleagues, and we were talking the other day how we can hear each other. And I don't know, I'm gonna have to ask him later. Did you do that shit on purpose? Everybody move your desks. Why? Just because. So real quick, this is a relation because what does one relate to?
Another one?
No. What does the number
The
one
x-axis.
relate to? No. What does the number one have a relationship with?
Input.
4.
Oh,
1 is the input, 4 is the output. There's a relationship between 1 and 4. What about 2?
5.
And? Okay. So a relation doesn't give a shit about if there's repeated inputs, outputs. It doesn't care. Could 2 people in here have the same size shoe on their left foot?
Yes.
Of course, right? Could one person have 2 different size shoes on their left foot?
No.
Yes.
Could. Does. Let me say it like this.
Oh,
No.
okay.
At the moment, nobody slipped a second shoe on top. Like, you put your shoe on, and then you put Shaquille O'Neal's shoe on. Which we all could probably do, right? You guys all with me? Okay. So that's going to come in important later. A function is a special type of relation. This is a relation. This is not a function. I like to think of it this way. This is vaguely true, but not exactly, but it's true enough. If I threw a ball and I said, 2 seconds later, where is the ball? And somebody says, it's 5 foot up in the air and it's 7 foot up in the air. What happened? What happened to the ball? What are you talking about? You guys all with me? Throw a ball, 2 seconds later. Where's the ball? It's 5 feet up in the air and it's 7 feet up in the air. No. Did somebody slice it the minute do you see what I'm saying? That doesn't make physical sense. There cannot be more than one output for a given input. For every input,
There's exactly one.
there can be only one output.
There'll be only one.
So why is this not a function?
Because it has two inputs that have.
There's an input that has, there's an input that has
Two different.
more than one output. Yes? And again, this is exactly at 1 second, where's the ball? 4 feet up in the air. At 2 seconds, where's the ball?
5 and 7.
5 and 7.
What? You guys with me? Okay, maybe. So I like to think of a function, and this is roughly true. It's not exactly true, but it's perfect. It's gonna. A function tries to say this is the kind of relationship that could actually be used in the real world. Right? I see a bird take off, and like 5 seconds later, where's the bird? I don't want you to give me 2 answers, because then I'm like, is that bird okay? Right? You guys got with me? Okay, maybe. So a function would be something like 2, 4, 3, 7, 5, 4. Now, real quick, does anyone think I've made a mistake? What shows up twice?
The 4.
But why is that okay?
It's
That's
not.
two
Is there
different-
any input that has more than one output?
No.
No. So what if I did not throw that marker? It's roughly, 2 feet? 2.5 feet, something. So at 0 seconds, where's the marker? We'll say 2 feet. Let's wait a second. Now where is it? Wait a second. Now where is it? Okay. So that's physically fine. You could have the same output. Not the problem. If somebody's standing still, they're in the same location, they can have the same output. I just can't have one input with two different outputs. Are you guys with me? Does that sound vaguely familiar? Okay, so a function is for every input, there can be only one output. Okay. So visually, what does that kind of look like? I'm going to make a lot of assumptions, by the way. I'm going to assume you guys can all graph points. If this is a bad assumption, come see me. So would this represent a function or not? And my marker is dying, poor little dude. Is that a function? What are the inputs of that function? Just the inputs.
-2.
-2.
0.
0.
1 and 2.
And what are the outputs? Just the outputs.
1.
Yeah, 1 is an output.
-1.
-1 is an output. 0 is an output.
Yeah, 1.
And 1 is an output again, right? I already listed it. I'll have to list it again. Does anyone remember what the collection of inputs, what we call that? All the x values, we call it the
Domain.
Domain. There. So this is the domain. Domain just means all of the inputs that have outputs. What's the other one? Range. Range just means all the outputs we get. And if you're going to list it, don't list something twice just because it shows up twice. Why is this a function? Why does this not violate?
Because it passes a vertical line first.
No, we're almost there.
Oh.
Definitionally, are there any inputs that have more than one output? No. What could I do to make this no longer a function? I can add 1 point. Give me one place I could add a point and it's not a function anymore.
0, 0.
Yeah, 0, 0. If I put a point, come here, little dying dude. If I put a point right there, why is that now no longer a function?
You've got 2 outputs for one.
Because there's 2 outputs for 1 input, yes. Do you see how if I draw a vertical line, it's cool everywhere except there? Vertical line tests, if you draw every vertical line and it only goes through once, that means that x value only has 1 output. So if I give you a picture like this, is this a function?
No,
Shit, no. Why?
because it goes like
Because,
that.
for example, this x has 3 outputs, yes? So I say, where's it after 5 seconds? You're like, 10 feet up in the air, 8 feet up in the air, and 2 feet below the ground. Okay, that's neat. All right, this should hopefully be reviewed. Is this coming back? Is this all right? Nothing amazing. So I like to give it to you visually, and I ask you, is it a function or not? I like to give it to you like with points, I like all kinds of ways. They all have the same idea. Well, what about, have you ever seen this kind of a picture before? 1, 2, 3, 4, 5.
Yes.
DNR, of course, is domain and range. Is that a function?
Yes.
Yes. There's no input that has more than 1 output. So what would it take for something to not be a function like that? I'd have to have 1, or any of these have 2 lines coming off of it, right? Because that would mean there's an input that has more than 1 output. Does that make sense?
Yes.
It wouldn't matter if more than one thing had the same output. That's okay. All right, I like it. Hey, Mikey. By the way, chapter 3 really still is a review chapter, to be honest. So just to let you know, it's a little less crazy than it used to be the last time I taught pre-calc. I went a little quickly over chapter 1 and 2. Now just sort of like pinpointed some things. We're still going to be a little quick at the beginning of the semester, and then we're going to slow down a bit as we get to really kind of new stuff. We're still in the kind of old stuff right now. Oh, good, I got a little bit of time. What was it, the last thing I wanted to do? Oh, yeah, cool. All right. Here we go. Yeah, cool, look at that. I'm further than I thought I was. So last thing, and I think I'm just gonna kind of like tease this, and we'll talk about it more next time. So really quick, if I give you a function, and you're not sure what it looks like, and some of you guys might know what that looks like. Does anyone know what that would look like if it graphed it? Yeah, parabola, right? A parabola. If I give you a function, you don't know what it looks like, what do you create? How do you create the graph? You got to get points. How do you get points? You make a x, y
Matrix?
table. You just start throwing stuff in, correct? You guys with me? So for example, what do I get when I put a negative 1?
0.
Yeah. Negative 1 squared is 1 minus 1 is 0. What do I get when I put a 0 in?
Negative 1.
Negative 1. What do I get when I put a 1 in?
0.
0. So there's that turning idea, right? Okay. Has anyone ever seen something that looks like this?
Yes.
All right, so this is what I mean by teaser. If you've never seen this before, we'll focus on that first thing next time. Does anyone know what that's called? How many pieces is this function broken up into?
2.
This is a piecewise function, not a pennywise function. Things don't float down here. Piecewise function, right? So if you've never heard of this before, I'll show you how this works. Really quick, if I put 2 in, if I had an input of 2, can anyone see which one of these I use?
The top one.
Because if for inputs at least 0, I use this one. For inputs less than 0, I use that one. You guys see what I'm saying? And why do I want that in the real world? Couldn't I have a rocket and then it hits something and then its trajectory changes completely? So don't I have one function up until a certain time and then another function takes over? That's the use of this in real life. So we'll talk about that first thing next time. Have a good weekend. Hopefully the rains aren't too bad this time. Last time my whole street was a freaking river. It was crazy. Yeah.
I still can't log into my Canvas.
Oh, I'm sorry. You sent me the email. I'm sorry.